All right, Dr. David Hardy with NCDA.
Good morning. For the last 2 or 3 years, I guess 3 years with soybeans and 2 years for corn, Carl and I have been working on potassium calibration work. And this talk is about those studies. We were fortunate enough to have the Corn Growers Association of North Carolina and also the soybean growers sponsor the studies for us. And we have other collaborators too. Kristen Hicks is my counterpart in the plant tissue lab at NCDA. And Ron Heidegger has been gracious enough to help us in harvesting the soybean plots. We certainly greatly appreciate that. What we've had are multiple on-farm tests and also sites at research stations for the past 3 years. These are small plot studies looking at broadcast applying potash at 0, 50, 100, 150, and 200 pounds of actual potash using muriate of potash 0060. What we're trying to do is certainly look at yield, but also determine other factors as well. Okay, here we go. This is the right talk. We're trying to characterize yield response, looking at different soil types, tillage equipments, new production practices. When our work was done many, many years ago, certainly there's been a number of changes in varieties and practices. We're looking at higher yields, and we think that's important to review and update our recommendations to see if they are providing the best recommendations to growers in North Carolina. We're looking at soil test data with these as well, and also looking at plant tissue data in addition to the yield. If we take a minute and look at plant uptake of K, what we see with corn and soybeans, if you notice for the growth stage R2 in soybeans, we're at about 20% uptake of K. So really, even at flowering time, we have very little potassium being taken up. If we look at corn at the same growth stage, you can see that we're nearly through with potassium uptake. So these two crops have very different needs in their uptake patterns as far as when they need potassium. What I would suggest to growers, especially on sandier soil types that may leach potassium, is to apply their potassium as late as possible toward planting time, or possibly even at your planting time if they can. For corn, you need to be pretty early, but certainly if you're on more sandier soil types or soil types could leach, not super, super early as far as that. The other thing to kind of glean from this slide here is to look at, you have a tremendous amount of potassium that's actually stored in the leaves in corn. That potassium doesn't have to mineralize to become available in the soil. Simply after several good rains after harvest, that potassium can be re-released into the soil for use. I thought I'd have better luck than Carl, but looks like I'm not. Okay. These are some slides I took from a study we had in the mountains. We had a yield response at this site, and we also had a yield response at a site in Terrell County last year with corn. And the development of the plant was so different, I thought this showed a pretty good potassium response to show you this morning. Here we have 0K to the far right, and you can see all the way up to 200 pounds per acre. If you look at just the development stage of this crop, you can see the potassium does a number of things in the plant, but certainly has a great impact on controlling crop development, the size of the plant, the height of the plant, the size of the stalk, and so forth. And I think you can vividly see that in these slides. Okay. This is from the same set of test plots. This is looking at brace roots. This is 0 pounds of potash. This is 200 pounds of potash. You can greatly see the brace root differences here. The K index of this site to begin with was about a 25. The recommendation was 100 pounds of potash from our lab. One thing we did with these studies, we took soil samples after we applied the potash to look at potassium uptake or potassium increases in the soil. This is showing the 0 to 4 or 0 to 8 inch depth after application in the uppermost layers. You can see that with the increments of K, we get these stair-step upwards of soil test K, showing the application. Looking down at a deeper depth, we did not really see that much leaching, so you see most of these lines here are pretty flat, indicating there wasn't much leaching of K from the uppermost layer. Looking at yield, for the past 2 years, we have had no yield response to potassium in any of our plots in the state, no matter what the soil test level was. And we have had some pretty good yields. Here we have 4 sets of data from eastern sites. These 2 sites in Perquimans, and this is the Beaufort County site here. You can see we're pushing up 50 to 70 bushels per acre. And you can see here the initial soil test levels were anywhere from 33 as a low up to a high of 68, with this number of pounds of K2O being recommended at these sites. But again, no yield response at all for about 20 sites of potassium with soybeans. Looking at potassium in the corn ear leaf, we sampled these. This is at tassel time for last year, showing various sites we had here. So you can see with our rates. And what you can see is generally a stair-step increase in potassium here with rates applied. You can see that most of these sites were below sufficiency. So you think possibly we would have gotten a response to potassium applied, but it turned out we only had 1 site to respond. This is the yield data for eastern sites this past year for Terrell, Pamlico, in 2 sites in Pamlico. We did get a response at Terrell County. Here the index was initially a 23, and once we applied 50 pounds per acre, we pretty much saw no further response to apply K. The 2 Pamlico sites, there was no yield response at all. We started off with around a 50 index and a 47 at those 2 sites with these recommendations. This is just showing this past year. We had a very, very wet year, as you know. This is a site called the Haslam Farm in Beaufort County. This is just showing symptoms of potassium deficiency early on and later on at a 0 pound rate and at 200 pound rate here. And you can still see some deficiency symptoms showing at 200 pounds per acre, it being a wet year. Okay. Just a summary to wrap up a few things we've learned from this study. I've showed you the data that soil test K increased in the surface layers after application, and we also saw K in the tissue increase as well after application. The tissue tended to increase with increasing rates of K, but is also influenced by growth stage. I did not show you any soybean data with this. Soybean being an early feeder of plant K did not show any increase at V3 and V5 growth stages, but we did see it at R2. So that's what that's associated with there. We recommend certainly using plant tissue testing in combination with soil testing to further determine the nutrient management of the crop. Sometimes we think that higher tissue levels of nutrients equate to higher yields. This is not the case. At some point in time, we reach a sufficiency level. So just because you have higher K in the plant does not equal higher yields. I would say the same thing with nitrogen. Just because you can push more nitrogen in the plant doesn't necessarily mean that you'll get higher yields. In some cases, you may consider saving money on K when there's a history of soil testing that indicating there's low K loss in the soil and an accumulation in the topsoil, especially in soils with higher seeds that are not prone to leach. That's one thing to think about. Based on our data from these studies, our recommendations appear to be working well for growers in North Carolina. There are a number of labs which have yield gold, yields or rates of recommendations. We do not have that philosophy in North Carolina because we don't want you to waste money in a sense. Our recommendations appear to be working well for high yielding environments with that. From a management perspective, again, You also may apply K later in soybeans than what you might consider otherwise, given soybeans have a later feeding pattern of potassium than corn does. So with that, I certainly thank you and also the Corn Growers and Soybean Growers Association in North Carolina. Sorry for the AV problems I had. I thought I learned from Carl, but evidently I didn't learn as well as I thought I did. So thank you.